Okay, so this is what we did, right? We use the list function to create a list of 100 elements from 1 to 100, and that's correct. And then we change the very first element to 200 and the very last element to 300. And now when you print it out, for this one, I missed the Y there. So now you see 200 and 300. Everybody, you can just do your thing. I'm just doing this recording so that if you come back, you can still see this, okay? And so this is one way to do the last element, to change the last element. And another way is this, right? Suppose you don't know how many elements are there in this list. You will get the length of the list minus 1. Remember, your last element is always at 1 less than the number of elements, right? So if you have 100 elements, the last element is at 99. So length of my list will give you 100 minus 1, that will give you 99. And you change it to 500 and you can see that works. Okay, so if you do this, this will throw an error because that index doesn't exist. The last element is at index 99. Okay, that's what this is. This is what we did, right? Now I'm asking you to give me a sublist, basically, from the first 50 elements. That means you will give me these elements, right? Give me these elements and put it into another list named what? Named your list. Let's do that. Okay, so your list is equal to my list. You remember this syntax from 0 to 49. We cannot do 50 because that would be 51 elements, right? From 0 to 49. That will give you the sublist from the first 50 elements. And when you print it out, you can see that is the elements, right? And when we, I just copied Yang's work here and just to show you it doesn't work because this has to be a list. It's not, it's not, my list is not a function, okay? And also, even if you use my list, somehow my screen is right here. Okay, let me put it here. So even if you use a list function, everybody, I used a list function, okay? If I use a list function, this will give me 1 to 49, right? And but my first element is 200, right? So you are really generating a new list. This is not the list, the sublist from my list, because my list, the first element is 200. If I change other elements, it's the same. But here, you will only, you need another parenthesis there, okay? If you say your list, you will see it's there. It's 1, 2, 3, so it's different from this one. The first element is 200, okay? Very good. So that's how you do that one. That's enough. I hope. So we are doing change the fifth element to 1000. Change the fifth element to 1000. So you have to do, I don't know how to make this go up. My list, I don't know if you can see, 4, sub 4. That's the fifth element. Okay. And now if you see if you print out my list, you will see the fifth element is 1000. 1, 2, 3, 4, 5, the fifth element. Because for a list, it always starts at 0. So you need to keep that in mind. Okay, good. Okay, now I think this time we can continue. Oh, I didn't share my screen just now, right? So That's the correct answer there. Okay. Okay, everybody. Okay, so that's the in operator. We did that. Replacing an element, we did that just now. We did review this part, right? This is how you replace an element. Okay, and this is to go through each element of the list. You use a for loop, and this is the length of the list. Remember, the last number is not included. So if you have 4 elements, the length is 4, but 4 is not included. So you can do this. We went through that. And we did this exercise last time. I think that was the end. So now let's look at the list methods for inserting and removing elements, okay? So the first one is L. It's just the name for a list. Whatever your list name is, you use your list name, okay? Not simply L. This L is just representing a generic list name. So L dot, remember you always have to use the dot, right, to call a method. So these are list methods. So L dot append element. So this will add an element to the end of L. That's append. And this one will add a list to the end of a list. That's the difference. The difference between append and extend is append adds one element, extend adds a list to the end. Okay, that's the difference. And this is insert. That means you insert at a certain index the element, the actual value. And pop will remove. Pop is actually really a method in stack, but somehow it's called pop here. Python is a newer language, so it's using some other languages not other language, but it's using a classic terminology. So I understand that. Okay, pop removes and returns the element at the end of the list. So whenever you call this, the end element will be removed, okay, and it gave you back. And this is saying remove the element at a certain index. So that's that. Any questions? I see someone's just wanted to let you know that. Oh, okay. Okay, so let's do exercises with, let's look at some exercises here, right? And then we can do some exercise. Let's look at the example. So this is a list. And if you print it out, if you want to look at the content of that variable, that's what that is. And now you are saying insert 10 into index 1. So now you see you have, that's the 0, that's 1, that is 10. And 2 is shifted to to be the third element, index 2, right? So originally it's like this. Now it's 1, 10, 2. That's what that means. Okay, insert. And insert 3, 25. So now 3, so this is 0, 1, 2, right? So now 0, 1, 2, 3, and 25. Okay, that's what this insert function does. Any questions, everybody? When you use it, you have to remember the first argument. Remember, these are called argument. The first argument is the index. The second argument is the value you want to insert into the list. You cannot change them. You cannot put the value first and then the index second. That will not work. Logically, that will be wrong, right? So always remember the first one is the index, the second one is the value. That's insert. And here is the append and extend. I did give you explanation here, right? Append means a new element at the end of the list. Extends means adds elements of its list argument. So you have to add a list to the end of the list. So let's look at these examples. That's what that is. And when you say append 3, now 3 is added to the end of the list, okay? And when you say extend, you have to give it a list, everybody. You cannot just give it one element. It has to be a list. And so now you can see, right? Those two lists are combined together. So you can add them together. You can also extend, you can also call that method, okay? So this is the same. You see, you just add it to it, right? Why did I have this? 1, 2, 3. Oh, I see. Okay, everybody, can you explain why this is so? I did this, and this will give you this, but when I actually do the example, it gives me this. Anyone who can explain that? I explained that last class. I say it again.
You didn't actually change the example, the value for it.
Exactly. This is called an expression, everybody. See, it's an expression. I did not. So this list is the evaluation of this expression. It did not actually change example. It did not change. However, this is calling a method. It changed. This is calling a method. It changed. Here, this is an expression, concatenation expression. It did not change example. That's why when you actually look at example, it's still the same. Okay, very good. Any questions about this, everybody? Okay, pop, right? When you pop, if you, this will give you back an element, okay? And it also removes it. So these methods really change things. These methods change things. So when you say example.pop, it will remove the last element, give you back. And now if you show example, you see the last element is gone, right? And you can pop a specific element. You can say pop the element at position 0, at index 0, and that's the value there at index 0. And when you look at it, it's changed. 1, the first index is gone. Now you have 2, 10, 11, 12. Okay, that's that. Any questions, everybody?
So when you pop the 0, the first index for the, I'm sorry, the 0 index, the 2 becomes the next 0.
0, yes. Now the index is 0, 1, 2.
Okay.
Yes. So this, if you say pop 0 again, this will be removed. Okay.
Okay.
Any other questions? Okay. Let's look at this. I believe is in the book also. So list exercise. Let's do it together in the chat, right? This way, everybody can participate. Okay. So assume that the variable data refers to this. Write the expressions that perform the following tasks. Replace the value at position 0 in data with the value's negation. Okay, everybody? So we want to change the first element to its negation, and you all did it correctly. Okay. You can do this, and some of you use that shorthand. I will do that too. Just okay. Okay. So now, if you evaluate the value of data, you can see that's changed to negative, right? That's very good. Excellent. Let's do the second one. Add the value 10 to the end of data. Let's do the second one. Very good. Okay, so add the value 10 at the end of the list. So you will use append. This will add it to the end, right? Okay, so that's good. That's good. Now you have to always remember the position is the first one, right? And the value is the second argument. So that's correct. Okay. So if you look at this, 0 is -5, 3 is 1, and 22 is at position 2. That's very good. That's correct. Okay. That's that one. And let's do the fourth one. Remove the value at position 1 in data. Remove the data at position 1, right? So pop. And that's number 3. That's value 3. If you look at it, right? That's the returned value. But now data is permanently changed. 3 is gone. 22 becomes position 1. Okay, that's good. That's good. Let's look at the next one. Add the values in the list new data to the end of data. Just assume new data has already been initialized. It has data in it. And let's do that. Okay, so we are doing add the values in the list new data to the end of data, right? So you have to assume new data has been initialized. So let's just initialize it. Okay, so this is new data. So you want to add this data to the end of data, you will do data. And you did it correctly, everybody, right? Extend, because you are adding a list, not an individual element. So you have to use the method extend and the name of the list, right? And now you look at it, it's added to the end. And that's correct. All of you answered correctly. You cannot do this because you don't do this because this is a name, right? This is the list name. And this is used to express a whole list, the value, the literal value of the whole list, like this, right? Or one element of the list. So this syntax is not correct. You don't use that square brackets because this is already the name of the list. Okay, very good, everybody. Let's do the last one. Locate the index of the value 7 in data safely. So I will let you work on that. And index, and you can see locate doesn't exist, right? So that's not a method. Find doesn't exist. That's not a method because those are the method names immediately come to your mind, right? And index is a method. It does give you the index. This is my list here. This is data, right? And 7 is at index 2. However, it's not safe. The reason is if I try to find an element that's not in it, it will throw an error. And this is ugly. We don't want to see that. We don't want the user to see that. That is what is meant by safely. That means even if it's not there, it will still be very graceful, very clean. You don't see this ugly error here. Okay, that's what that means. Do you think you want another 5 minutes to work that out, everybody? Safely. Find it safely. So I will give you another 5 minutes. Not see the screen. I will put it here. If 7 in data, okay, print data index 7. So you added a safety measure there, basically, right? Okay, that's 4. 0, 1, 2, 3, 4. That's correct. Ariel, you have to be at work around 11:20 for today only, right? Ariel, okay, yeah. And make sure you watch watch the schedule. Watch the what? Watch the video. Okay. Okay. So let's say we find. Let's see if we can have something that's not in the list, and that's why we say it's safe, right? Okay. You see, nothing happens. So you basically you can add it here, right? Okay. So you can say else print not in, right? I can do that. So let's see, it says not in. So great work, everybody. That's correct. And Kyle did a function definition. So you know what, Kyle, I will not go over this because this will confuse students, but they will understand this hopefully in the third week or beginning next week, the second class of next week, because this is more advanced. You're using a function to find it, right? So you define the function and you're using function. So we will not look at that, but obviously you are advanced there. Very good. You worked it out in your own way. So I will just use this. This is what we learned, and this is correct. That's very good, everybody. That's very good. Okay, so in this case, what you can do is you can ask the user, right? Number is equal to input, enter a number, for example, enter a number, right? Ask the user to enter. And the user enters 234. And you can put this code there. And I should just copy this here, right? This way you are really, you are working with the user to see if what the user entered is in the list, you know, so you can put this into actual use, right? Oh, this is still 7. I thought I used the, okay, let's do it. So how do I change this, everybody? Look at what I'm doing. How do you change this? I want to find if the user input is in the list. How do I do that?
Don't you have to change
So
at the data index, don't you have to change the 7 to the user index, the number? Or am I just looking at crazy?
okay, so what do I put here?
So sorry. So if number is equal, or sorry, if number in data, print data dot index and then number.
Yes, yes, and Omkar answered here in the chat also. Yes, that's correct. Okay, so now, so you can really use this to to do other things. Another way to do this is you can use a for loop, right? Going from the beginning of the list to the end of the list, and to see if that value is 7. If it is 7, you get the index. So you can do it in multiple ways. And this is great. I like it. This is very good. Some of you answered this. This is great. So any questions, everybody? How about this? Let's do one more exercise, okay? I will put this here. Let's do one more. So another one is you will ask the user to enter data, to enter 10 numbers, let's say five numbers. Using a list, okay, using a list, get the total. That doesn't, get the total. Oh, we did that in get the total. How about, okay, do you want to do this or should we go on, everybody? I need to pause. Okay. You see, that's the thing. I cannot. Okay, let's do this. Okay, search the in operator. And you already used it just now, everybody, right? You use the in operator. You said if 7 in list. Okay, the in operator, and we learned that also, determines an element's presence or absence, but does not return the position of an element. So this is a list, and use the method index to locate an element's position in the list. Okay. So this is the list. Target is 45. If target in list, then print the index. Else print. I think my original yesterday when I was looking over at this, my original slide said print -1. And I looked at that, I thought, oh, that was not correct. Why? Why is this not correct, everybody? If I simply do print -1, why is that not correct?
Because that's just going to print -1. It's not actually like yeah, sorry.
Okay, anyone else? Why would this not work? No one?
Is it because
So we just did the exercise. Safely find the index of 7, right? We found that. We did that. Okay. So that is using the in operator and using the index method. Okay. And now sorting a list. Sort means putting things in order. Okay, that means that's what sort is. Arrange elements in order. So a list elements are always ordered by position. This list, for example, they are ordered by position 0, 1, 2, 3. But if you order the content, it should be 2, 4, 8, 10, right? This list should be ordered. That should be 2, 4, 8, 10 from low to high. So you can impose a natural ordering. That is the natural ordering from low to high. So when the elements can be related by comparing them with these operators, they can be sorted. Okay. So can you sort everything? No. But if you can compare the elements, this means if you can compare the elements with these operators, then you can sort them. So you can compare 4 is greater than 2. That's true. So now you know you can sort them. Or you can say 4 is less than 2. That's false. So put 2 there and put 4 there, right? That's how you sort them. You compare them. So this is the method. Okay, example.sort. And now your example is permanently changed. This is calling this method sort on this example, and it's changed. Somehow I think I closed it, right? Okay, so that's that. Any questions? It's as simple as that. You can sort a list using the method sort. Let's do an exercise. So let's still use data. Okay, right? So now if I print it out, it's in this order, but if I do data sort, that means I'm sorting it, okay? And then if I look at data, it will be like this. It's sorted. This is very convenient, right? It's sorted. It can be sorted because each item can be compared with another one using less than, greater than, or equal to. That's why you can call sort on it. Okay, that's the sort method. Any questions, everybody? Is there a question there? Okay. Okay, so mutator methods and the value none. So sort, as you can see, right? It changes the list. Just like the previous one, append, extend, pop, insert. Those methods are all mutator methods. Mutate, what does mutate mean, everybody? What does it mean, mutate?
To change.
Change, exactly, change. If you remember the X-Men, they are called mutants, right? Because they change. So mutate means change. Mutator is a noun. It means you change things. It's a method that changes things. So insert, append, extend, sort, they are all mutator methods. That means they change the list. And you can see that. Here I'm calling sort, and data is changed permanently, right? Okay, so if I do data.append 90, now data is permanently changed. So these methods are called mutator methods. That's what that means. Okay, mutator methods here. Here, right? Okay, so mutator methods, these are usually return no value of interest to the caller. It doesn't return anything. So if you look at this, when we mutate, when we say sort, it doesn't return you anything, right? You think about it, when we do data.index 34, it returns you the index, right? It gives you the index back here. But if you oops. Data.insert to 34, why do I always use 34? 30, then it doesn't return you anything. So mutator methods do not return anything, but it changes the object. In this case, data, that's the object. Okay, so it doesn't return anything. But Python automatically returns the special value of none. Okay, it returns the special value of none. And that is very dangerous, actually, sometimes. So let's look at this. You sort it, and now you want to print. Oh, here. Okay, this is assign this, everybody. Questions? No? Okay, so here, when I say data insert, I'm not assigning it to anything, right? When I say data sort, I'm not assigning it to anything. But if you assign it to something, let's say data.sort, okay? Because I inserted an element there, right? So now, because this will return the value of none, you are assigning none to L. Oh, my L doesn't have anything anyway, so let's do this. Okay, so L is equal to data dot, let's see, data dot sort. Okay, let's just do this. And now, because this returns a value of none, your L is completely lost. Okay. If you say print L, it will print none. So your L lost this data. Do you understand it, everybody? Look at it. So this is saying, do not do assignment. So we always say an expression, right? If you don't assign it, it doesn't change anything. But with mutator methods, they change things. And they in Python, it just assigns about it returns a value of none. So if you assign it to a list, to a variable, that variable will lose its original data, original value, and become none. So now you see your list is completely gone. These values are gone. It returns none. So it's very dangerous. That's why we say it's dangerous. Do you understand me, everybody? So when you do data.sort, you do not assign it to anything, okay? So now you see data still have this value. But if you say, I'm going to sort it and assign it, okay, that's fine, but your data now is none. Nothing, right? And when you print it out, you will see it will say none. Does that make sense, everybody? Do you understand the significance of this? Do you understand that? Yes? Okay. Anyone else? Do you feel that you understand it? So for these mutator methods, when they change the original variable, you do not use assignment when you call them. So do not do this, right? Do not do this because append is changing the list. So these methods will automatically return a special value of none. And then when you print it out, it will be none. So that's why I'm saying it's dangerous. Don't do that. Okay. So if you don't have any questions here, we will go on. Do you understand it? Difficult to understand because it's more abstract. Okay. Aliasing and side effects. Mutable property of lists. That means a list can be changed, right? That's the mutable property. A list can be changed. Leads to interesting phenomena. Okay, so look at this. This is a list here, right? This is a list. Okay. Second equals to first. So we are assigning this list to another name, second. And what this does is it means this is the list, right? This is the list. And first, originally, it's pointing to it. Remember, this is just a variable, right? It's a variable name. It's pointing to this location in memory, which contains 3 elements. And second, and when you do second equals to first, it means you're assigning first to second. When you do that, you are actually assigning the address pointed to by first to second. So your second is pointing to the same address. Okay, so first and second are pointing to the same address. You are not creating another list. You are just pointing to the same address. That's what this is. So when you do first, it shows you this. When you do second, it shows you this also. These are not 2 separate lists. They are the same list in the same location. Just now it has 2 names. Okay. And if you change first sub 1 equals to 99, and if you print it out, now this element is changed. And if you print out second, you see it's changed. Why? Because they are two names for one location, 2 different names for one room, for one storage place. So that's why if you change one element, when you reference both names, both are changed. So we call this phenomenon, first and second are called aliases. They are just different names for the same thing. They refer to the exact same list object. Does that make sense, everybody?
Yes.
Okay. Let's see. To prevent aliasing, create a new object and copy contents of the original. Okay, so because when you do this simple assignment, you are not creating, once again, you are not creating a second list. You are using two different names to reference the same list. So if you change the list element through one name, when you reference it through another name, it's changed also because they are referencing the same object, right? So then sometimes you will have problems because if you intend them to be two separate lists and you want to reference that, you want to deal with them differently, they are actually the same list. Let me just do this. Okay, I'm going to close this. Okay, so if you say list one is equal to, oops. Okay, 3 elements. And then you say list 2. You say, let me make a copy of that. I want to keep a copy and change the other one. Well, if you do this, you say, I'm making a copy. Are you making a copy, everybody? Yes or no?
No.
No, 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 no.
Not really.
Not really,
Making
no.
an exact.
Yeah, you were thinking you were making a copy, and now you can do list 1. You can deal with list 1 and list 2 separately. No, they are aliases, right? So if you change list 2 to a certain value, then, oops, list 2. Then both list 1 and list 2 are changed. That's the danger. So you are not making a copy. You are referencing exactly the same object. Okay, because you're just changing the, you're just referencing the same address. So that's what this means. That's why it says to, it's very dangerous. To prevent aliasing, create a new object and copy contents of the original. Okay, so here is the example. So create a third list. And when you do this, you are saying third is not just a regular variable. It's a list. That's what that is saying. So this means it's a list variable, okay? And then you can call this method. If you don't do this, if you simply, let me do this. If you simply say third, then, you know, it's not a list. You cannot append, right? Because append is a mutator method of the list object. So you have to say, okay, I'm making sure a third is a list. That's how you express that. Creating a list variable, okay? That's what it is doing. And using the for loop for element in first, third, append, right? Because we are doing element by element. We are doing a whole element. We are doing a whole new list. So we add each element to third. And now you can see first is this, and third is this, right? So you are copying the elements to third. Now you have 2 different list variables. They are not referencing the same memory address. They are referencing 2 different addresses, and therefore they are 2 different lists. And so when you change the index 1 element of first, it's not affecting the elements in third. Does that make sense, everybody?
Yes.
Yes, everybody, you understand this, right? So this is to prevent aliasing, because aliases are referencing the same thing. So you want to separate them, you need to copy each element one by one into another list. You cannot simply say this list is equal to that list. do this, you are pointing to the same memory location, the same list. But when you copy, you are creating a different list variable. And so now you have two different lists. So if you change this one, it does not affect this list. Okay, that's what that is. Any questions? So we can do a list of 3, okay, so equals to an empty list, right? That's an empty list. So you are saying, okay, list 3 is a list. And how about this? Let's see if we can do this. Dot extend. We should be able to list 2, right? Okay, list 3. So you can use this syntax to simply copy each element, right? That's using the for loop to copy each element. You can also simply, because this is an empty list, you can simply extend, add that list to the end of this list, but this list is empty, so now there are 2 different things. Okay, so if I change list 2, change list 2 sub 2, okay, to 300, okay. Now list 2 is changed, but list 3 should remain the same, right? So now we have 2 different lists. Looking at this code, everybody, tell me who is an alias of whom? Looking at my code, I know it's messy, but who is an alias of whom?
List 2 is an alias of list 1?
Yes, list 2 is an alias of list 1. What about list 3? Is list 3 an alias of list 2?
No,
No, why not?
it's its own list.
Yes, it's a separate list, okay? It's a separate list, and that's why when you change the element in list 2, okay, it's changed, but list 3 is not affected. It's still the same. Okay, that is this part. Any questions, everybody? And that's what this is doing. I'm just giving you the example here, right? First is this, third is this. And if you change the element in first, that list is changed, but third is not changed because they are 2 separate lists. And make sure you remember, this is how you create a new list. I think for your 5.2, you are required to do this. So just know that this is how you can create an empty list. And make sure it's a list, but it's empty, right? Okay. Any questions? Okay. Let's look at this. This is, as I said, this is very abstract, okay? Very abstract. And originally, I look at the book and it's a little bit ambiguous. So I changed this, okay? So I'm just listing it out. When we talk about equality, there are 2 different equalities. One is object equality and one is structural equality. Okay, so we call this object identity, and this one we call it structural equivalence. Okay, object identity means several variables reference the same object. Okay, because it's the same memory address, the same location. So these variables are aliases of one another. That's called object identity. That means they are the same. They are the same object. They are just aliases to one another. I'm giving you an everyday example. One person has several names. This person can be called by his first name, his last name, his nickname, whatever name, right? All these different names are referencing the same person. That's called object identity. It's the same person. To test object identity, we use the operator is. Okay, that's the operator. We use that to test if the two objects are the same, are aliases. So here, if I say list 3 is list 1, what would return, everybody?
False.
False.
False, false, because they are not aliases with each other, right? But if I do this, what will return?
True.
True, yes, because list 1 and list 2 are aliases to each other. They are referencing exactly the same location, so it returns true. That's called object identity, okay? We use the operator is to test object identity. Now, the next identity is, the next equality is structural equivalence. Structural equivalence means two or more variables have the same content, okay? But they reside in different addresses, locations, and thus are different references. Okay, so once again, let's do that. So list 1 is this, right? I need to close this and let's just do it again. Okay, so list 1 is equal to 5, 6, 7, 91. Oops, 91, right? Okay. So this is list 1, right? And if we do list 1 equals, no, list 2 equals to list 1. Now they are aliases, you know that. So when we say list 2 is list 1, it returns true. You understand that. Okay, now do list 1 and list 2 have the same content? Everybody, do they have the same content?
Yes.
Yes. So when you say list 2 equal, oh, I forgot to tell you, right? We use the equals, double equal sign to test that. So this is testing the content. Okay, list 2, 1, it returns true. Okay. Okay, let's do list 3. I'm just doing the original one. Okay, app empty list, right? I will just use this simple method 3.extend list 1. Okay, and now list 3 is this, right? The same. So when I do list 3 is list 1, what will return?
False.
False.
False. Yes, that's true. But when I do list 3 double equal sign list 1, what will return?
True.
True.
Because they have the same content. That's called a structural equivalence. Okay. So 2 or more variables have the same content, but they reside in different addresses and locations, and thus are different. They are referenced differently, right? They are different references. An everyday example would be Christmas gifts. Who doesn't love Christmas gifts? Assume a company gives employees an envelope, each with his or her name on the envelope, but inside every envelope contains a gift card of $100. So the contents are the same, but the reference variable, the name on the envelope, the names are different. So that's the structural equivalence, okay? Contents, we are looking at contents. To test structural equivalence, we use the operator double equal sign, okay? So just remember that. And here, I hope you don't see this, but I have to mention this. Please note that this also returns true if two objects are aliases of one another. And that's where the confusing part is. That's why I'm putting this at the end. The original slide from the book is they put this just all jumbled together. that really is confusing. So I put this at last, okay. But to distinguish the two equalities, avoid using this to test object identity. So just remember this. So to test object identity, to see if they are aliases to one another, which operator do you use?
Is.
Is, yes. To test if they are the same content, which operator do you use?
Equals equals.
Equals equals, yes. That's what this is. Any questions? If you continue to class 2, we will discuss this also. And this is sometimes the confusing part. But if you can understand it here, that would be great. That's good. Okay, so that's what this is. Okay, list 1 and list 2 are aliases. So when you test them using is, it returns true. List 3 and list 1 are 2 different objects. So when you use is to test them, it returns false. But when you, because they have the same content, when you use double equal sign, they return true. Okay, that's this part. Any questions? Okay. Let's look at another one. So this is example. This is the example. Okay. First, second, this is aliases, right? So when you test second is first, it will return true because they are aliases of one another. They point to the same location, just like this, right? Okay. Now, oh, you can make a list this way also. This is instead of copying one by one, you are just making a list of first and assign it to third, just like what I did. I did extend, right? We are using list function to build the third list. So now first is second, true. First equals to second. Remember, this is where the confusing part is. This is where I'm saying, please note, this also returns true if 2 objects are aliases of each other. Okay, so it also tests object identity. And this is for computer organization, by the way. Okay, so when you do this, okay, it's testing the structural. Oh, this one, first is second. This is correct, right? Okay, structural equivalence, that's true. And first it's equal to third, it's true. Because first and third have the same contents. So that's true. First is third. Oh, I didn't do the other one. Yeah, that's good. Okay, first is third, false. They are not the same because they are 2 separate lists, right? This is another list. So this is examples illustrating that. And I do have these comments there. Okay, that's what we did this just now also. Any questions about this, everybody? Okay, for this one, I think this will take a longer time to explain. And we only have this one left. So next week, we will, next Tuesday. Okay. You know what? I'm going to poll you. I'm going to poll you. Did I share the result just now? I didn't. That's the result. Okay. Of the, do you understand this? It's 11:27, so you might not. Do you want to continue so I can explain this, or do you want to